It has feeding, thirst, and satiety centers, so damage to this, and some persons may feel hungry all the time, or they may never feel hungry at all. You know, they have to regulate their intake just based on what's on the plate. It controls body temperature, so this is associated even with fevers because you can reset your body temperature in this area to raise the temperature to help combat disease. And it is one of several structures associated with regulating sleep. So you can see it's actually composed of lots of little different parts with different activities. You don't need to know the parts, you don't need to know the activities. The pituitary, located here, is connected to the hypothalamus by a funnel-like structure called the infundibulum, and that word actually means funnel. The only place I've ever heard the word infundibulum used was in the book The Sirens of Titan by Kurt Vonnegut, or Kilgore Trout, depending on how you want to look at it. But the infundibulum suspends the pituitary, and again, the pituitary is a major regulator of homeostasis. Also, as I said before, some input, taste, smell, hearing information can go through this area. Smell being extremely strong. I did not mention the sense of smell does pass directly through here, whereas other parts of the brain are associated with our other senses. The sense of smell is very basic. We have bacteria that can respond to chemoreceptors and function with smell. So since the hypothalamus is also associated with memory, it's not surprising that smell can play a huge part in triggering memories. The epithalamus we won't talk about that much, but but it does contain the pineal gland, which is an endocrine gland. We'll talk about that a lot more later on. It's one of my favorite glands. It is also associated with regulating sleep. And then we have the choroid plexus. And let me go back here. You see we've got this ventricle, which is a hollowed out area that has cerebral spinal fluid. And the choroid plexus forms the cerebral spinal fluid. We've got the brain stem, and that attaches to the inferior part of the cerebrum, and it extends out and becomes the spinal cord. So parts of the brain stem include the midbrain, the pons, and the medulla oblongata. And there's the brain stem there. Now, we've got the pons, which is this big lump here. We've got the medulla oblongata. Not going to worry about cerebral peduncles. So I'm not going to worry about the corpora quadrigemina. The thing that you should be aware of is that this midbrain has reflex centers for vision and hearing. So a person could have significant damage to the cerebrum, the frontal lobe. They may be clinically brain dead, but these reflex centers would still be in place, and so they may still follow movement. They may respond when someone says their name by turning their head toward them. And for people who are unaware of this, they may think that their person is still alive, when in fact they are brain dead. These are just reflexes that will occur regardless of whether a person has higher functioning or not. Okay, so there's the midbrain. Not a lot to tell you there, other than what we've already discussed. Now, another region of the brain is the pons, and this is a big bulging area located here. And mostly fiber tracts, includes nuclei associated with breathing. So damage here could impact breathing. The specific terms for breathing are pneumotaxic and apneustic. You don't need to know those. Just be aware that the pons is associated with breathing. It's about an inch long and just before, really, above the medulla oblongata, which is right where the brain exits and becomes the spinal cord. Now, the medulla oblongata is the lowest part of the brain stem. It merges into the spinal cord, and it has some fiber tracts that contain some control centers like heart rate control, blood pressure regulation, breathing, swallowing, vomiting. So again, a person could be brain dead, but they're still going to breathe. And if you put something in their mouth, they will either swallow it or they'll throw it up. So again, these are reflex activities. There's your medulla oblongata. It also is associated somewhat with breathing in that it sets a basic rhythm of breathing. It smooths out what is being sent by the pons. And reflex centers, coughing, sneezing, swallowing, etc. Now, injury to the medulla, because it is important, a hard blow to the back of the head down near the spine can be fatal, as you can end up not being able to breathe, not control blood pressure, not control heart rate. Now, cranial nerves. Cranial nerves don't go down the spinal cord. They don't cross. They simply exit out of openings in the skull. Since we've been through the brain already, since we've been through the axial skeleton and looked at the skull, you'll note that there are lots of little holes and openings there. These are passageways for cranial nerves and vessels that enter the brain. Now, cranial nerve malfunctions will result in a problem on the same side of the brain, or same side of the body as the brain. So a person hypothetically could have a stroke that impacted part of the cerebrum and parts of where the cranial nerves exit, and they might not, they might have part of their face slump on one side, but their arm on the opposite side also can curl up. So, now, there is sort of a generalized area we call the reticular formation, and it takes in information from all over the body, and the important thing that it does is in the reticular activating system, which also plays into sleep and wake cycles. Basically, this area of the brain decides whether there is sufficient input to keep you awake. It decides whether you're tired enough to go to sleep. So a person who has damage to the reticular activating system may experience narcolepsy in the absence of any stimulus or something monotonous. They may just doze off. So driving can come into play. If you're tired and you're driving, and it's night and all you see are the little stripes flipping back and across to you, you can end up being lulled to sleep. Basically, because the reticular activating system is not getting enough stimulus to keep you awake. So again, reticular activating system, very diffuse. It's got some input that comes from the optic nerve, so bright light coming in the morning will wake you up. Sounds in the morning will wake you up. The thing that gets you out of bed in the morning is the reticular activating system.